lesson, number 36. Make sure you have that one out in front of you. We are leaving parabolas behind, which I'm sure you're excited about. We're going to look at overcoming a third obstacle to factoring. What if there are no real number solutions? All right. So let's go ahead and look at the classwork, the opening exercise, and see what it says. Find all solutions to each of the systems of equations below using any method. All right. So you could graph them. You could solve them like a systems, whatever you would like to do. I'm going to graph them just because I see that I'm not going to be all lines. I do see some things that look like they may be possible circles, maybe a parabola. So let's just kind of look at this. The first one I see, I do have two lines. So I want to put them in the form of y is equal to mx plus b. So let's go ahead and we'll do 2x plus 1 is equal to 4y. All I did was took my 4y over and brought my 1 over, just because I felt that was a little bit easier to do. So I get 1/2 x plus 1/4 is equal to y. Probably not going to be the easiest to graph, but that's okay. We can make our boxes work. All right, so that's 1. 3x minus 6y, so it's 3x. I'm going to bring the 4 over, and I'm going to take the 6y over. Divide by 6. So I get 1/2 x minus, I'm going to do 2/3 is equal to y. All right, so I'm going to go ahead and graph these. All right, so my y-intercept is 1/4. So I think what I'm going to do is I'm going to let my boxes equal 1/2. So 1/4, 1/2, 3/4, 1. All right, so we'll label that 1, 1/2, or 1/4, 1/2, 2. All right, that way we kind of have an idea. So this will be 1, this will be 2. All right, and then my slope is 1/2. So I'm going to go up 1 and over 2. So here it's going to be roughly that. All right, so I'll go ahead and connect that. All right. So then we've got my y-intercept is negative 2/3. Unfortunately, that's not going to be the easiest. So 2/3 is a little bit more than 1/2, but a little bit less than. So we'll go 2/3 here. And my slope is up 1 and over 2. So it would be, around in there. I'm a little off, but that's okay. What do I see? Is there a solution? There's no real solution here. They are parallel lines. I should know that because they have the same slope. And remember, lines that have the same slope are parallel lines. All right, let's look at the second one. All right, we'll draw the second one. All right, let's see what we've got. I've got y is equal to 2x minus 5. So that means that my y-intercept is negative 5. And my slope is 2 up 2 over 1, 2 over 1. So here's my line. All right. And then I have points here. So, the easiest 5 points to do. So if -2, so that would be, if x was -2, that would be 4 minus 2, which is 2. If x were 2, 2 times 2 is 4, minus 2 is 2. If x were -1, that would be 1 minus 2, that would be -1. If x were 1, 1 minus 2 would be -1. And if x were 0, that would be -2. So then let's graph that. So I have -2, 2. I have 2, 2. I have -1, 1. I'm sorry. -1, -1. And 1, -1. And then 0, -2. So here's my parabola. What do we see? Once again, there are no visible real solutions. All right, let's do the last one. So I know that they are both circles because they are x squared plus y squared is equal to 1. So I know my first circle has a center of 0, 0. And then the yep, that's it. The radius is the square root of 1, so that would be 1. So my first circle is going to look like this. Alright, very rough, but that's okay. My second circle, I know once again does have a center of 0, 0. And it has a radius of the square root of 4, which is 2. So once again, what do I see? All three of these do not have real number solutions. So there are no real number solutions for any of these. All right, we had parallel lines, we had a parabola and a line that never intersected, and we had two circles that never intersected. So there are no real number solutions here. All right? Make sure that you sketch these and make sure that you turn these in with your paper unless you did it a different way, and then you'll need to show me how you did it on your paper. Okay, so why? Why do these not have real number solutions? Well, in this case, the lines never intersect. They are parallel lines. Once again, I know that by the slope of my lines, parallel lines have the same slope. All right? We could use an algebraic approach, solving the systems of equations. If I solve the systems of equations, we're going to get a false statement at the end. And when you get a false statement, then you know that there is no solution. All right, so what can we do? What do we do when we do not have real number solutions? Number one, are there any real number solutions to the system y is equal to 4 and x squared plus y squared is equal to 2? Support your findings both analytically and graphically. All right, so how can I do this? Well, the first thing I can do is I know what y is equal to, so I can substitute y into my second equation. So I get x squared plus 4 squared is equal to 2. So that would be x squared plus 16 is equal to 2. X squared is equal to negative 14. Since x squared is non-negative for all real numbers, there is no real number solution. So, no real solution here. So it says solve it graphically. Well, I know this is a circle. So the center is 0, 0, and the square root of 2. So the square root of 2, if you actually figure that out, is, okay, sorry, I was in a program, about 1.4. So my circle is going to kind of look like this. And once again, that is a rough circle. And y is equal to 4. The line's going to go through here. So I can see visibly that there are no real number solutions here. All right? All right. So let's talk about this for just a second. I'm going to show you 3 parabolas. Okay? And I hope I can get all this in the screen at once. Okay. So I want you to kind of look at these 3 parabolas. Remember that a parabola with a vertical axis of symmetry is the graph of the equation in the form of y is equal to ax squared plus bx plus c. Alright, for some real number that a, b, and c with a not equaling 0. Alright, so we can consider the solutions of the quadratic equation ax squared plus bx plus c is equal to 0 to be the x-coordinates of the solution to the systems of equations of y is equal to ax squared plus bx plus c and y is equal to 0. Which of these 3 parabolas are represented by a quadratic equation y is equal to ax squared plus bx plus c so that no solution to ax squared plus bx plus c is equal to 0. Well, let's look at this. Parabola 1 is a graph that does not intersect the x-axis. So no x-intercepts of the parabola means that there are no solutions in the association of the equation ax squared plus bx plus c, because I have nothing to plug in for x. If you will notice, all of these other parabolas intersect the x-axis. Alright? Alright, so now, let's go. I pulled those away too quickly. I want to look at them just a little bit more. Let's look at parabola 2. Okay? Which is the graph of the equation y is equal to 8 minus x plus 1 quantity squared? How many solutions are there to the equation 8 minus x plus 1 quantity squared is equal to 0? Okay, well, because parabola 2 intersects the x-axis twice, the system consisting of y is equal to 8 minus parentheses x plus 1 quantity squared, and y is equal to 0 has 2 real solutions. Alright, so because it intersects the x-axis at 2 places, there are 2 real solutions. One would be positive, here. The other would be negative here. All right? Looking at parabola 3 is the graph of the equation y is equal to x squared. All right? How does the graph tell us how many solutions there are to x squared is equal to 0? Well, because parabola 3 intersects the x-axis at one point, and that is 0, 0, that means there is exactly one solution. All right? So, let's kind of go back and review for just a second. There are no solutions to this because it does not cross the x-axis. There are exactly 2 solutions to this one because it crosses the x-axis at 2 places. And here, there is exactly 1 solution because it touches the x-axis in 1 spot. Okay? All right. Hopefully that makes a little bit of sense to you. All right. So let's go on to number 2. Let me back my camera back out just a little bit. All right. It says, does the line y is equal to x intersect the parabola y is equal to negative x squared? If so, how many times and where? Draw a graph on the same set of axes. All right, so I know that both of them equal y. So I can set these equal to each other. So I can set x equal to negative x squared. All right? So now I'm going to take x squared over, so I get x squared plus x is equal to 0. I can take an x out. When I do that, I have x plus 1 is equal to 0. So now I'm going to set each part equal to 0, and I get x is equal to 0, and x is equal to negative 1. So, let's see what that means. Does that mean I have 2 solutions? All right? So if x equals 0, then y is equal to 0. Okay? So, plugging it back in, if x is equal to 0, then y would be equal to 0. So it tells me that I should have an intersection at 0, 0. If I plug negative 1 back in, then negative 1 squared is 1 times that negative is negative 1. So it's telling me that I should have negative 1, negative 1. All right, well, let's see if that's the case. All right, let's graph this. Identifying my x and y axes. And I'm not drawing them perfectly. Y is equal to x. Well, I need to know what that is. So just plugging some points in. If x is 0, y is 0. If x is 1, y is 1. Alright, so this is what my line would look like. Alright, so there's my line. Alright, plugging in here for x and y. If x is 0, y would be 0. This is a parabola, sorry, not a line. So if x is 0, y would be 0. If x is 1, so I would have negative 1. If x is negative 1, I would have negative 1. If x was 2, alright, I would get 2 squared, which is 4. That would be a negative 4. So if x is negative 2, it would be 4. So here's my parabola. So I see that in this case, there are two distinct points that my parabola and my line intersect. So these are the solutions to my system. All right. Does the line y is equal to negative x intersect the circle x squared plus y squared is equal to 1? If so, how many times and where? Draw graphs on the same set of axes. Once again, I can, if y is equal to negative x, then I can plug that into my equation. So I'd get x squared minus, plus negative x squared is equal to 1. So I get x squared plus negative x times negative x is x squared is equal to 1. All right. So I get, what did I do here? Oh, no, I'm good. So I have 2x squared is equal to 1. Divide by 2. X squared is equal to 1/2. All right, I have to take the square root of that. So I get x is equal to the square root of 1/2. Which means that x is equal to, that's the square root of 1 over the square root of 2. So multiply everything times the square root of 2. I get the square root of 2 over 2. All right. So it would be, x would be the square root of 2 over 2 or the negative square root of 2 over 2. Because remember, when we're talking about square roots, they could be positive or negative. All right, so plugging that back in, if x is this, then y would be, so it would tell me that if x is negative square root of 2 over 2, plugging that back in for y, or for x, would give me that y would be positive square root of 2 over 2. And then if x were the square root of 2 over 2, then y would be negative square root of 2 over 2. So it's telling me that these should be my two solutions. Now the nice thing is, well, not so nice I guess, is that the square root of 2 is not the easiest to find. So I'm probably not going to be very specific on my graph, but it's okay. All right, so y is equal to negative x. So if x is 0, y is 0. If x is 1, y is negative 1. If x is 2, y is negative 2. So my line is going to look like this. All right. And my circle, my center is at 0, 0. And the radius is 1. So here's my circle. And I see that I do have two distinct points where they intersect. I can't really tell exactly what they are. I would have to use a graphing calculator, but I do see that there are two distinct points. All right, last question here. Does the line y is equal to 5 intersect the parabola y is equal to 4 minus x squared, why or why not? Draw the graph on the same set of axes. All right, so once again, let's plug in 5 for y. So I get 5 is equal to 4 minus x squared. Take my 4 over 1 is equal to negative x squared. I'm going to switch these, so I get x squared is equal to negative 1. All right. Taking the square root of, so I can't take the square root of a negative number, so therefore it seems to appear that there are no real solutions. Well, let's see if that's the case in our graph. So y is equal to 5. 1, 2, 3, 4, 5. So here's my line right here. Alright. And then let's look at if I gotta do some points here. So my x and y. So if we'll do -1, 0, and 1. So I get if x is -1, so that would be 1 negative. So 4 minus 1 would be 3. If x is 0, y would be 4. If x is 1, y would be 3. Alright, so 0, 1, 2, 3, 4. 1 would be 1, 2, 3, 3. You're going to see that your parabola opens downward. So therefore, it appears to be no real solution. Okay? It appears to be no real solution. Alright. Guys, key points really quickly. An equation or a system of equations may have one or more solutions in real numbers, or it may have no real solutions. Two graphs that do not intersect in a real plane describe a system of two equations without a real solution. Alright, and then a quadratic equation in the form of ax squared plus bx plus c is equal to 0 that has no real solutions indicates that the graph of y is equal to ax squared plus bx plus c does not intersect the x-axis. Alright, that was our parabola part. Alright guys, hope you have a great rest of the week, and I will talk to you next week.